Let's begin by finding the gradient of OA. To find the gradient of a straight line, I need either the equation of the line or I need two sets of coordinates. Well, I know that one of the coordinates is at the origin, simple. Then I need the coordinate of A. What's so unique about A is that it is the point of intersection between L1 and L2. When two lines intersect, we are doing simultaneous equation. That is what we are trying to find out over here. Where the x and y values coincide has to be my equation, my coordinates of A. So equation number one, equation number two, I'm not going to waste time. Work it out, we find that A has coordinates of 16 and 8. X value of 16, y coordinate of 8. So based on this, the gradient of OA will be 8 over 16, which is half. Because the other point is at the origin. Now we're going to find the equation of MC, the gradient of MC. To do that, I need the coordinates of C and the coordinates of M. Coordinates of M is easy because it is the midpoint of OA. So M is going to be half of 16, which is 8, half of 8, which is 4. This is 8, and here we have 4. Now I need the coordinates for C. C is the x-intercept of our line number 2. X-intercept refers to y value equals to 0. Substitute y equals to 0 here. 3 times of 0 is 4x minus 40. X must be equal to 10. So C has a x coordinate of 10. So the gradient of MC take a rise over the run. So we've got 4 units over the run of 2 units, which is negative 2 over here. That's our gradient. Okay, it's sloping downwards, so the gradient is negative 2. So we were doing all this because we wanted to determine when we multiply these two gradients together, whether we end up with negative 1. If we do, then the two lines must be perpendicular. And just by looking at this, yeah, we know that they give us negative 1. So gradient OA times gradient MC. So presentation, half times negative 2. We get negative 1. Based on this, we are going to conclude. Therefore, angle OMC equals to 90 degrees. So come with a plan for your coordinate geometry and continue from there. Yes? Find the length and compare. What do you mean? We are AM, AC, and MC. Okay, then what do you do? Converse of Pythagoras theorem, right? What does the Pythagoras theorem state? How does the Pythagoras theorem start? If a triangle is right angle triangle, right? Is this a right angle triangle already? Not yet. So you need to use the converse. That means you're going to be proving the 3 sides. You check their squares. When the sum of 2 of them add up to be the 3rd square, then you conclude that it is a right angle triangle. So that's the converse. Yes, using that will work, but you must use converse, not Pythagoras. Yeah. Next, part 2. Find the ratio of area of triangle OAB. OAB to OAC. Okay, so let's find the area of OAB first. How many methods are there, do you know, to calculate this area of this triangle? Keeping in mind that we are doing A maths over here. Okay, or please look out for a short moment at the screen. I'm trying to find the shaded area of this triangle. What methods do you have to find area of a plane figure in coordinate geometry? Shoelace method. Do you want to use the shoelace method here? Do you really want to use the shoelace method? No, you don't. Well, it will work. Definitely it will work. But we already have the x and y coordinates of A, 16, 8. The area of a triangle is given by half times base times height also, right? What is the base over here for this shaded triangle? Our OB. OB is our base. We can set it as the base. If OB is the base, then the height will be this horizontal distance, which is 16. Okay, so this is a shorter way of finding the area of a triangle in A maths. Now, the next triangle, OAC. So, can we use something similar, or do we still need to use shoelace? OAC. This time we want this area. What will you set as the base? OC. And OC has a value of 10. So half times 10. And what is the height? Perpendicular height over here. That is 8. Okay, so don't need to use shoelace method 2 times for this 3-mark question. Okay, one last question on integration. Question 12. Express this in the form blah blah blah, A and B and integers. Okay, we realize that the degree of the polynomial on top is 1. The degree at the bottom is also 1. So we can use our long division. Even if we don't use long division, there are other methods. Okay, so we are dividing 2x by 2x plus 3. So 1 times of 2x, 1 times of 3. We're going to subtract. So obviously the 2x will disappear. That's why we are doing long division. So here we have a plus 0. 0 minus 3. Negative 3 remaining. So our 2x over 2x plus 3 will be 1 plus the remainder, which is negative 3 over 2x plus 3. Okay, and here we have expressed it in the form a plus b over 2x plus 3. They did not request for it, but if they did, our a value is 1, our b value is negative 3. Sometimes I think it is quite easy to earn the marks in A maths. For very few steps, they are quite generous. So that's part 1. Part 2, differentiating d over dx, x ln 2x plus 3. So presentation, your notation must be correct. Differentiating x ln 2x plus 3 with respect to x. If you like, you can say let y equals to x ln 2x plus 3 dy dx. If you rather do that, it's fine. But you're spending a little bit more time and you're introducing a y. So when we differentiate this is a product of 2 functions. First we have x and we have a ln. So copy, differentiate plus differentiate, copy. Let's copy and let's differentiate. When we differentiate a ln, it's very simple. Just 1 over. Here we have 2x plus 3. Then we multiply it with the differentiation of inside the bracket. Okay, from outside to inside for our ln. So we have copied and differentiated. Next, we must differentiate and copy. Differentiate x, we get 1. So we're left with copy ln 2x plus 3. So dy dx, differentiating it once, we get 2x over 2x plus 3 plus ln 2x plus 3. Next, we still want to differentiate it another time. Wait, did they? Oh no, just differentiate once only. Okay, I thought they wanted to differentiate it twice. So now, part 3. Using the results of part 1 and 2, determine integrating this. They specifically told you to use the results of part 1 and part 2. If you don't have part 1 and part 2, it is going to be very difficult for you to integrate this at our level, at our O-level standard at the moment. So now, since they told us to differentiate in part 2, and this is our answer, we are going to reverse it. So if I were to integrate 2x over 2x plus 3 plus ln 2x plus 3, if I were to integrate all of this, if I integrate the right hand side, the result will be integrating the left hand side. But remember, on the left hand side, we originally have differentiate x ln 2x plus 3. If I integrate a differentiate, I get back the same thing, right? X ln 2x plus 3. Remember that our integration is a reverse of differentiation. But over here, we need to add an arbitrary constant c. So don't forget about this. Now let us find, is there an integral of ln 2x plus 3 in whatever we have written? Integrate fraction plus ln. Oh, we see that something familiar just popped up. Ln 2x plus 3, ln 2x plus 3. So integrating these two, the sum of these two will be the same as integrating them separately. So integrate 2x over 2x plus 3 with respect to x plus integrate ln 2x plus 3 dx equals to x ln 2x plus 3 plus c. They only want this. So make this the subject. Integrate ln 2x plus 3 dx is going to be x ln 2x plus 3 plus c, minus away our integrating 2x over 2x plus 3 with respect to x. There's nothing for us to do over here. C is an arbitrary constant. Our focus is now on integrating this. They also told us to use our result in part 1. Earlier in part 1, we expressed 2x over 2x plus 3 as partial fraction. 2x over 2x plus 3 is the same as 1 plus a negative 3 over 2x plus 3. Okay, so we have x ln 2x plus 3 plus c minus integrate. We're going to replace it with whatever we found in part 1. 1 plus negative 3 over 2x plus 3 dx. Integrate 1, you get x. Here we have plus integrate 3, 1 over 2x plus 3 dx. This over here will result in a ln after you integrate. Okay, and I think you can finish up everything already. No, but take note, when you integrate this, you will end up with another arbitrary constant. This time you will have to call it C1 because you have already used C earlier on. Okay, so from here we pop out another C1. At the final step, you can combine your C and C1 into C2. Okay? Arbitrary constants, they are not the same. We have two different integrations, so we have two different arbitrary constants. When you add two arbitrary constants, you get another arbitrary constant. So labeling is important. Huh?